Supposedly it says I'm live, and I woke up this morning deciding that actually it's from last night. I was talking to Healthy Developer, which is a YouTube author or content provider, and he kind of inspired me to mm, do a little bit more with YouTube. The thing with me is I am very rough around the edges, and I kind of recognize my limitations, and I know that I just don't have it in me to properly produce a high quality YouTube video on any given topic because I just don't have the patience to use other software tools to edit, and that stuff takes time, right? So what does that mean? Uh, it means that although I recognize, not necessarily embrace, but although I recognize my limitations and what I'm willing to do, what not to do, I decided that maybe I should experiment a little bit. And in addition to masterminds, in addition to working on that mobile delivery app that I've been doing, just do a brain dump. Maybe this brain dump would be for like maybe 15 minutes to half an hour. Hopefully, I can cut it off within half an hour. But there's like, I was thinking this notion of the four, I don't know if I should spell it out or not, the four limitations of the developer, okay? And so, because this isn't the actual editor, I have to manually put in spaces. And this is what I came up with. The four limitations of the OOP developer: unable to separate state from behavior, unable to write testable code, unable to model a domain, unable to isolate responsibilities. So what do I mean by that? If we start off with number one, unable to separate state from behavior, the limitation of the typical OOP developer is all about gang of four design patterns and solid, principles from your Uncle Bob Martin, Robert C. Martin. And so maybe I should type that out, right? So you say, hold on, over here we say design patterns, and then I think the abbreviation is gang. How do they do this? Gang of four. I put zero. Gang of four. GOF. Of course, we can just type it out, right? We'd say gang, and then we'd say and then we can just say four. Maybe that's clearer. Okay. So unable to separate state from behavior. Examples are design patterns. So when I say design patterns, you have the state pattern, you have the go back. You have the strategy pattern. Strategy, I could just say state strategy. You have what else do you have? You have the observer pattern. You have the chain of command. You have facade. I don't know how to spell facade, something like that, right? So you have, I thought it was like 23 different patterns. And I remember when I was honing my skills in software development, and I was reading the Gang of Four book and struggling to read it. And then I got my hands on the Heads Up Design Patterns book, and it read like a comic book. And it was awesome reading. And I thought I was the ish. I was purposely going out of my way to inject design patterns into every single code base I could find. And did it increase my knowledge? Was it very helpful? Did it elevate my consciousness or my awareness? Absolutely. What else did it do? It made the code more complicated. And it made my code more complicated, right? Speaking for myself. And here's the thing. Even though implementing or utilizing design patterns is kind of like a status symbol for me, it really just demonstrated how clever I thought I was. And the more design patterns I implemented, the less automated tests I wrote. And the thing was that my code wasn't inherently testable because I had all these design patterns sprinkled within the code base. So that's the thing. And that's kind of like maybe an awe moment or an epiphany is I find that, well, I don't really write design patterns that much. I rarely write them, right? And it's not really a conscious decision. It's more of I have my own patterns that I write, and they don't really have a reliance on state the way that your typical object developers rely on state. Meaning that if I'm using a traditional OOP language, in this case like C#, I just have static classes that have static methods only. No properties, no member variables. I only have static classes that expose behavior, static behavior at that. And that's it. And then I have another category of classes which only expose state, meaning that these are, your person class or your, I don't know, your animal class, whatever you want to expose as state, meaning that it only exposes the properties. It doesn't have any operations or behavior associated to it. Those are other type of classes that I write. And then I can join them, right? Meaning that maybe conjoin is not the right term, but if I only have behavior with no state right here, and I only have state with no behavior right there, then I found in my personal experience that it's just a lot easier to write straightforward code, period. I don't have to deal with I just don't have to deal with the complexity of coupled state with behavior. I don't have to perform as many ceremonies to get things to work. Like it just removes a whole class of errors, right? And with a typical developer, they just don't understand that concept. And why don't they understand that concept? It's because they only know one paradigm, and they're a slave to that paradigm. It's the metaphor of using a hammer as your only tool for everything, right? In this case, your typical OOP developer, they use a sledgehammer for everything because they don't know any better. Facts. So that was your unable to separate state from behavior. Is there anything else I could add to this? I said design patterns. I thought I mentioned another node in here. Oh yeah. Your solid, right? And so your solid is single responsibility principle, open close principle, list call, whatever. I don't even know how to say the L was like list call. I don't know how to say it. List coniv. I don't remember what L stood for. But it was like list coniv substitution principle. I can't remember. I don't know what I is, inversion of control or something. IDK. And D was dry. Don't repeat yourself, right? And so, yeah, I guess I'm still staying on the first node. With solid, now it introduces not only you could choose to do design patterns, but solid is it's basically a set of principles to prevent you from making your code worse than it already is. I mean, that's what it is, right? And so there's some value in it, absolutely, right? Single response. I can't spell responsibility. Let's say principle. Absolutely, like strive for it. Period. No, no disagreement, right? But this is probably going to leak into another one of the four limitations. But here's the issue with OOP developers, right? When we say single responsibility, they are literally uh, thinking about the class. They're literally thinking about the method, right? What they're not taking into consideration is a level above that, right? They're not. Hold on, I'll probably hit Shift Tab. Why is it still going that way? Okay, that's weird. What they're not taking into consideration is uh, the library, right? AKA project. Okay. So what I mean by that is your typical OOP developer, they're not even going to consider a library being part of or being considered for the single responsibility principle. Like they don't have any concept of that because what they're used to doing is they're used to out the floodgates creating your monolith. All right, we'll call this monolith core, and then within your monolith, they'll just automatically do your views folder, your controllers or view models folder, and then they'll have your services folder, and then they'll have your. Why is not? Did my tab really break? I think my tab broke. Hold on. Well, both keys don't work. Okay, so I don't know how to shift in the other direction. All right, so your typical OOP developer, right? They forget about the library also conforming or complying with single responsibility principle. And so, like I said, they'll create they'll add a core project, aka library, to their solution. Then they'll just add a views folder, a controllers or view models folder, services folder. They'll do a repositories folder, okay? And all this is within one library, right? And not only that, but they continue to break the single responsibility principle because they'll for that application, regardless of if it's a web application or if it's a mobile app or if it's some back end services. Well, I guess a back end they're not going to have views. Yeah, maybe they could. I don't know. I'm not a web developer. What they do is they take all the views within that application. So it may be account account login, right? Maybe one page that they throw in that folder for views. But then they'll take they'll take a what we want to call it options trade or exercise options. How about that? Hold on, where am I at? So they may do an exercise options page, and they'll throw that in the views folder, completely unrelated to account login, by the way. And then they'll have a what else may be in there? They may have a transaction history page, right? And then they may have a purple dinosaur page, right? And so the point that I'm trying to stress is that the typical object-oriented programmer, they just arbitrarily throw unrelated files into one folder if that folder represents a layer of the system. In this case, that layer of the system is going to be views. All right. In another case, the layer of the system is going to be various controllers or view models, depending on your architectural design pattern. Right. Another layer of that system is going to be services, and they'll just arbitrarily throw in unrelated um, unrelated files have nothing to do with the other in that folder or in that directory that's supposed to represent that layer of the system. And so this does violate the single responsibility principle, because what's really happening is, well, these folders are not really being responsible. They're not really maintaining responsibility for any particular domain of the system, right? When we talk about business domain or business subdomain, or even feature, right? They're modeling their system after layers of abstraction, and it has nothing to do with the actual application itself, the application's intent. So what do I mean by that? Well, my argument is when you open up a solution, when you examine the code base for an application or for a system, it should be blatantly obvious what that application does, right? This application, when you have these folders in here, you have a core folder, and then you have views, controllers, services, repositories. That doesn't tell me anything about what this application is supposed to do. I have no clue where to navigate to troubleshoot a feature, right? Now, one could say, sure, you do. You at least know, if you're troubleshooting, where the code for the UI is, hence views, where the code for the controllers or view models are, where the files for the services are. Yeah. Well, again, you're going to you literally are treating these as buckets, and you're throwing files that have no relation to one another, with the exception of the layer that they fit in. You're throwing them all together. And so single responsibility principle is really keep code together that tends to change together, and pull code apart that tends to change for different reasons. And when you model your code this way, in which your typical OOP developer does, you're really not complying with that principle. And when it comes to systems maintenance, this is a maintenance concern, and it just makes it harder to find what you need to make alterations. Your typical OOP developer doesn't even see that, because they've been doing this so long, and they have no other paradigm shift or approach, that they just take this for granted, right? So yeah, OOP developers suck. All right, so what else is there? I talked about design patterns. I talked about solid. I talked about modeling the libraries and files in the application, and how your typical developer just doesn't understand that concept, at least how to do it properly or better than how they currently do it, for that matter. What else? Well, let's talk about number 2. Your typical object-oriented programmer, they're unable to write testable code. Okay, so what does that mean? Well, your typical object-oriented developer, based on what I stated, I don't understand why Shift Tab does not work on here. Your typical object-oriented developer, they rely on state a lot. Like, remember, these are the people that when you have a class, when you have a class, then that class shall expose properties, it shall expose member variables, and that class shall expose methods, right? Right. And well, maybe when I say expose, it's not going to expose member variables. It'll expose properties, and it'll expose behavior, right? Maybe I could say behavior like that. And so that's what your classes do. And then maybe they don't expose, but the implementation details are reliance on member variables. And it's a reliance on private methods, right? And okay, so what? Okay, well, I'm just saying, this is what your typical OOP developer relies on, right? And so what happens is whenever you combine state with behavior or translate it, how about I say this? Whenever your behavior is tightly coupled to state, tightly coupled to coupled. I can't spell coupled. I can spell coupled. Coupled. I don't know how to spell. Whenever your behavior is tightly coupled to internal state, then I would say that you may experience some complexity, right? Introduces. I can't spell anything. Additional complexity. Because what really happens? Well, if you think about it, you have a method. My method, right? You have a method that I don't know. I guess I could use braces, right? You have a method that, let's say it has some args on it. arg1, arg2, right? You have a method that not only receives arguments, right? And that's fine. I'm totally down with that. But you have a method that now has the ability to reach outside of its scope and say, my member variable equals arg1, I don't know, plus arg2, or we could say do something, and then we'll just have arg1, right? We do something like that. So they say, all right, well, what's wrong with that? All right, well, remember that there's a couple things. The difference between a method and a function is a function, well, a pure function, will execute and be, what's the word, deterministic, meaning that regardless, you can pass in the same arguments over and over and over again, and you're going to get the same output, right? You're going to get the same state returned. I'm not even sure if I should really say state. You're going to get the same output return, right? That's a function. A method is not a function. A method, here's the issues with the method. A method, not only do you pass it arguments, right? But when these methods act on their parameters, that's not the only data that they're acting on. These methods have the ability, and the majority of the time do, reach outside of its scope, right? In addition to its parameters, it has the ability to access data outside of its execution block. And I guess that's what I'm trying to articulate is a method has the ability to reach outside of its scope and rely on data that is external to it. And that causes issues for testability, right? So in this example right here, we have this notion of my member variable, right? And so my member variable may be a member variable of a class. And this method is literally reaching outside of its scope and mutating data that's not declared for the function itself, right? That's what it's doing. And so that's the issue with methods, right? And that's the issue with the typical OOP developer not being able to write testable code is they rely on objects, right? And if we say objects, we're saying objects are a combination of properties and behavior. And it's because they are tightly coupling those two sectors, should I say, that it introduces complexity for testing code, because this isn't really a thoroughly controlled environment when your scope of execution has the ability to reach outside of itself and rely on external data that's not defined within its initial signature, right? This is a signature. My method arg1, arg2. Where in the F did my member variable come from? And how is anybody going to know that's reviewing this code that this method is actually mutating values outside of it, right? There's no way you're going to know that unless you examine the implementation details of that method, which brings me to this, right? Get rid of this. Your typical object-oriented programmer, they need to examine the implementation details for a method or a function, because that's what object-oriented programming paradigm pretty much causes. Instead of just relying on the function signature or the method signature, that should tell you that really is a spec for what that method does to a system. And honestly, it's not even what the method does to a system. It's what the method does, period. That result is going to be processed by the system, but the method doesn't do anything to the system. Or I'm sorry, the function doesn't do anything to the system, but the method does. Why? Because the method not only processes the code within its scope, but it reaches outside of itself and it mutates, modifies, molests values that aren't really declared as part of its signature at all. And so, but your typical object-oriented developer, they rely on that. They rely on methods that do more than what's declared on its actual signature itself. And that's why OOP developers suck. All right, so yeah, I probably could have articulated that better, but I'm just live streaming, right? None of this is really thought out. I don't really have a preconceived outline. I'm just going, right? So I discussed unable to write testable code and some of the reasons behind that. Dealing with state, right? If your method goes outside of itself and mutates stuff, mutates state, and that isn't necessarily declared in the method signature, it's going to make it harder to test. Whenever you have state combined with behavior and you introduce concurrency, that's going to cause some issues with testability, right? That introduces race conditions, potentially, etc. So, and yeah, your OOP developer, they're going to start introducing lots, mutexes, semifors, all the stuff that I never really understood. That just introduces additional complexity. Why? Because, well, object-oriented programming is from like 20 plus years ago, and yet we're still treating it as if it's a modern language, and it's not. And we have a whole bunch of object-oriented developers, and they're not modern, they're antique, right? They're antique. So what else? I talked about unable to separate state from behavior, unable to write testable code, unable to model a domain. Okay, what does that mean? Well, it's unable to model a domain is, well, what does OOP teach us, right? Object-oriented programming says model real world systems, right? Or systems. Or maybe we say model real world objects, right? That's what object-oriented programming, based on my experience, try to like, I'm trying to use a complicated word so I can sound clever. And I can't think of that word, but I was indoctrinated by, hey, object-oriented programming, you model real-world objects, right? And well, okay, but does that really work, right? Does that really work, right? And does what really work? Does modeling real-world objects really work, right? So maybe I'll throw this in here. Say, does modeling real world objects really work? And the answer is no, it doesn't. It doesn't work. Well, what do you mean it doesn't work? This is how we build systems. We model real world objects, right? All right, right, Bizmonger? No, no, no. Your typical object-oriented developer is going to believe that because they have no other paradigm to really relate to, right? But we don't really model real world objects. That doesn't help us build a system. It doesn't. If anything, it diminishes our ability to build a system of value. So if modeling real world objects don't really work for building systems that deliver value, then what does? Well, I'll tell you what's better, right? This may not be like the answer to everything, right? The silver bullet, but what works better is we don't model the real world objects that a system relies on. Instead, we model the rules that a system needs to comply with, right? Comply with. Okay. So, you marinate on that for a second, right? And maybe we could translate this a different way. Maybe we could say, go back. Maybe we could say, you model the rules that a system relies on, right? So you can look at it, in one or two ways, right? Model the rules that a system needs to comply with, or you can say model the rules that a system relies on. I think I like the second one better. Come here. So you model the rules that a system relies on is completely different from modeling real world objects, right? These when you say you're modeling real world objects, well, these objects can really be disparate, arbitrary, right? When you're modeling rules, well, every system has rules. I mean, honestly, I could probably look up the definition of system, and I haven't done this before, but I feel like probably should have rules somewhere in its definition. A system is a group of interacting or interrelated entities that form a unified whole. The system surrounded and influenced by its environment is described by its boundaries, structure, and purpose. I like purpose, right? Purpose to me means rule. Well, it doesn't. And expressed in its functioning, right? Systems are the subjects of study of systems theory, all right? So did the term rules ever come up in here? No. So I'll take an L on that. But the closest I got to it was that when it said boundaries right here, and it said purpose right there, and when it said expressed in its functioning, I would like to say that right there means rules. And this is me trying to finagle that so I don't look too bad. But if we go back a system really is a set of rules, right? A system can be a game, a system can be a court, a system can be, well, I just gave you the definition, right? So again, when we look at number 3 for the 4 limitations of a OOP developer, it's they just struggle to model a domain properly, right? And what does that lead to? Well, it led to what I said earlier when I was talking about unable to separate state from behavior and also unable to write testable code. When I started talking about your design patterns and your solid principles, all these right here, my friend, all these are band-aids, right? They're bandages, right? They're gum that's been stuck in saliva for like half an hour, and then they're stuck onto some hole as a patch, right? It's duct tape. This is duct tape, right? Duct tape is not pretty. It's but it serves a purpose, right? Because it's just trying to keep things together. This is Elmer's glue, right? Design patterns and solid, these are Elmer's glue, right? That's the metaphor that I'm using. And well, to your typical object-oriented developer, they're like, no, this is the way it's done. And I'm telling you, it's the way that's done because the typical object-oriented developer has no other paradigm to relate to. So they're a slave of the system that they're caged in. You like the way I use that, right? Okay. Good play on words. All right. So they're unable to model a domain. So what does that mean? Well, I told you what they try to do is they try to use real world objects instead of using the actual rules that the system relies on. So they say, no, Scott, that's not true, right? In object-oriented programming, we have interfaces. Hold up, my caption's messed up. In object-oriented programming, we have interfaces, okay? And I would say, well, this is true, right? Absolutely, this is true. And well, what's an interface in object-oriented programming? Well, an interface is basically a class's, can I say class? Sure, for right now, a class agrees, I can't spell agree. A class agrees, however you spell agree, whatever. Class agrees to implement a specified method, right? That's what an interface really is, right? Class agrees to implement a specified method, right? It has a contractual, class has contractual obligation to implement a specified method, like that, right? Class has contractual obligation, spell obligation wrong, to implement a specified method, okay? That's what an interface is, all right? So Shirley Scott, that, AKA Bizmonger, right? That kind of like negates your whole notion of unable to model a domain. Well, I don't think it does, right? Because here's the thing. The issue with interfaces is an interface must be derived from an object, right? So you have an interface that must be derived from an object. And my argument is I don't like the fact that in order for me to use an interface, I have to instantiate. I have to go through the ceremony of declaring and instantiating an object, right? Right. So in order for me to translate it, in order for me to utilize an interface, I need to declare I need to declare an object each time. And then I need to, what else I need to do? Well, I mean, you could declare and instantiate at the same time, but because I want to support my argument, I'm going to purposely say instantiate the objects, all right? And then you can call that single operation that you've been wanting to call right? Call a single operation, right? And so here's the thing. The issue with interfaces and object-oriented programming is like, I just want to call the operation. That's it. I, I don't care about an object. The object, it doesn't matter to me, right? Now, if it means that I need to call the qualified name, the qualified path of the operation, like namespace, um, yeah, that's fine, right? I feel like that's a lot easier than going through the ceremony of making this everything revolve around the object because like here's the thing, right? And this is where I try to streamline my argument is in object-oriented programming, we want to do real-world objects, right? And that's what the issue is everything is based on objects, right? And even when you want to call a simple operation that needs to be part of a contractual agreement, well, we still have this dependency on nope, it needs to come from an object, right? And so that's the issue. I don't want to rely on objects. I don't want to declare instantiate an object just so I could call an operation that needs to fit into a contract, right? I just don't want to do that. So here, that's my response to. Oh no, no, no. We have interfaces, so yeah, those are the rules, right? And yeah, they're partially right, but there's still ceremony involved. And so then someone may say, well, I mean, Scott, like, dude, you could just use a singleton and your problem is going to be solved, right? If your issue is that you have to declare an object each time you want to call an operation as part of a contractual agreement, surely, Scott, you can use a singleton. And I would say this is true. Uh, what is a singleton? A singleton pretty much guarantees that there can only be a single instance of an object in your system. Uh, okay, or in your runtime. And then they could say, well, what's the alternative to a singleton? And you could say in IOC container derived instance, something like that, right? Or IOC derived because inversion of control. Yeah, I could say container, right? Right. And so these are your two techniques for ensuring that there's a single instance, right? Because the IOC container is really it's a glorified dictionary, right? That's all the IOC container is a dictionary. But people, your object-oriented programmers, they want to sound cool. They want to say dependency injection all the time, and they want to see IOC all the time. But it's a dictionary. That's all it is. The dictionary is the key is an interface. The value is the actual concrete class or instance. And that's it. So what now? What Desmugger? You in order for you to model a system, you need to have interfaces. Okay. And I say, well, interfaces, that's too heavy. No, it's not. It's not at all. You just create a singleton or IOC container. Okay, well, it is heavy because you have to go through the rigmarole. I can't say I don't even know what the word is. I say rigmarole. I don't know what the actual phrase is. But you have to go through the ceremony of defining a singleton just so that you can call a single operation instead of creating an object each and every single time. Or you have to go through the ceremony of creating an IOC container, aka glorified dictionary, right? Register the dependency to an interface just so that you can serve this interface within this notion that we call object-oriented programming. And like I'm just not with the ceremony, man. It's like that's too much. I just wanna like call an operation that belongs to a contract that I declare. And that's it. And my friend, within object-oriented programming, that doesn't exist. Right? So that's my argument for number 3. And I guess we can get to number 4. Unable to isolate responsibilities. Do I want to get to number 4 yet? Is there anything else for me to say in number 3? Unable to model a domain. Oh, yeah. in number three, I kind of touched on it in number one. But remember when I said that your typical object-oriented developer, they're going to have a folder called core, and then they're going to have folders called views, folders called controllers or view models. They're going to have a folder called services, and they're going to have a folder called repositories. Repositories, whatever. And like, yeah, so they're going to have their only library that encompasses the features of the application, right? The responsibilities of the application is usually going to be in this core library that they have, whatever they name it. And then they have these folders in here, and these folders will encompass all the presentation pages for the application, right? Your controllers, your view models, it encompasses all that. So again, as I stated in number one, you don't know what the application does. When you look at the file system for that solution or for that code base, you have no clue what that application does. You have no clue what that system does. And so it, again, violates this whole notion of single responsibility principle, because your typical object-oriented developer thinks that the SRP, aka single responsibility principle, only applies towards classes and methods. And they're just clueless because they forget about libraries being responsible for a single responsibility. But again, I elaborated on that with the bullet point number one. All right, so that was my second reasoning for why OOP developers are unable to model domains properly. It was because they don't understand the concept of libraries within a solution and how libraries can actually focus on the responsibility of a subdomain for an application. They don't understand that part. When I say subdomain, like a business subdomain. Okay, so the last one is unable to isolate responsibilities. Kind of just touched on that, right? Let's see, when I wrote that, did I mean something else specifically that's unrelated to number one? Unable to isolate responsibilities. I think I kind of touched on that. What was I thinking when I wrote down number four? Yeah, so your typical OOP developer, like I said, they create several folders: views folder, view models folder, controllers folder, repository folder, services folder, blah blah blah. But they don't isolate the responsibilities of the actual business domain that the application or system is being written for. And so, how can I mean, I really think I just went through this with these other items right here. I'm trying to figure out if I had something in mind specifically. I feel like I did, but I'm just unable to pull it from my memory reserve, right? Yeah. Well, what I will say is your typical OOP developer, they when they think about a system, they think about nouns, right? Because remember, we're modeling real world objects. All right, that's what they think a system is. And my argument is, well, you shouldn't model real world objects. You should model the rules that a system relies on in order for it to deliver value. Right. So your OOP developer, they rely on nouns, right? And well, your other developer, see, I'm going to leave the other developer out, right? Other developers, right? Okay, you can say your FP developer, right? They tend to rely on verbs, right? Rely on verbs, okay? Verbs, aka operations, right? So what does that mean? What that means is, so when they rely on nouns, objects, for OOP developer, a functional programmer relies on verbs and operations. So what that means is your OOP developer is going to say the system shall have a widget, and a widget is going to have a do something, right? Behavior. I don't know if something has an E on it. Yeah, okay, it does. It's going to have a do something behavior, all right? And then the system shall have a fig jig, okay? And that figma jig shall have or expose an operation called foo, right? And so that's the way a OOP developer thinks. They think that in order to implement a system, you need to implement the nouns of that system. And so that system gets flushed out based on them describing all the nouns in that system, right? And you can see this is one of the major reasons why projects fail because of this philosophy, this paradigm of designing a system. They design it based on nouns, okay? So your FP programmer, what do they do? Well, they say, okay, there's going to be business domain A. There's going to be business domain B. There's going to be business domain C. All right, and so then they're going to say that business domain A is going to expose do something, and then they're going to say that business domain B is going to expose a do something else, and like that's where we'll get rid of business domain C, right? And so then when they first establish the domains, or they partition the system that they're going to design, and then they partition it into subdomains, right? Business domains, and then they define the operations, right? So it's really, instead of do something, it's really like operation one, okay, and then operation two, and it really applies towards any domain, right? They focus on the segment or sectors of that system, and then they focus on, okay, what operations does the system provide? And these operations are really analogous to rules for a given system, rules for the subdomain of the given system, right? And so here's the part. Well, Bismonger, right? Like, okay, but how are the nouns generated? Because we see that the limitations of an OOP developer is they're noun driven, right? And the productivity of a functional programmer is their operations driven, right? Well, here's the answer. Right? Nouns are generated by declaring your operations, right? Well, what do you mean? I don't understand. Nouns are generated by declaring your operations. In order for operation one to be successful, what does it need to be successful, right? And in order for operation one to be successful, it needs to have a widget, right? It needs to have a widget. Well, okay, it needs to have a widget, but how is it successful? Well, once operation one has a widget to process, then it is going to produce it's going to maybe produce a results that is going to be a fig, a jig, or an error, right? That's the rule. You declare your operations. When declaring your operations, you say, in order for this operation of this business domain to be successful, it needs a widget. And the result of feeding this operation a widget has to be of this type. Well, this type may be successful, right? Or it what's this we're gonna call? Or it may not. If it's not, it's going to return an error. So, I mean, this is an arbitrary signature, right? You're going to get a result. I kind of wrote this wrong. You're going to get a result, right? But your result may be success, or it may not be. And so this result really should be the maybe, like that. Okay, and yeah, that's I would argue is a better way of decomposing a system and flushing out the operations of a system. And when you flesh out the operations of the system, and you think of the what a system needs to be successful and what it needs to produce, then yeah, then you really think about what an operation needs to be successful and what an operation needs to produce as a result of what we feed that operation, right? So same thing applies for business domain B, right? It's the same thing. And so my argument is one of the limitations of a OOP developer is they don't understand this paradigm. Why should they? They've been fed so much complexity about what an object-oriented system requires, design patterns, solid principles. I do agree with automated tests. I agree with test-driven development. Thing is the majority of your developers out there, and the developers of the systems out there that are object-oriented, they just lack it. The code's not testable, and because there's so much discipline required, and it's an antique paradigm. So this was my attempt, whether I failed at it or not, to basically articulate the 4 limitations of the object-oriented developer. And this is really just me just doing a brain dump. Like, none of this is really scripted. It's just me like just kind of being condescending, poking, making fun of, low self-esteem to make myself feel better. Yep, it's all of that. But also part of it is to really expose some truth with the limitations of object-oriented programming and the people that try to utilize it to deliver value for their customers. And that's the goal, is we should be delivering value to our customers. Our customers are paying us, and we should really be refining our technique so that we could save them a lot of money, or we can make them a hell of money. And that's it, right? Biz Monger signing off. I'm out. I'm going to stop sharing. And is there anything else on here I want to say, share? Probably not. I'm going to say end.